This is how I currently store my pliers. It's a knife rack screwed to the side of my 3D printer enclosure, and it is super annoying. When I first put this thing in, I thought it was a cool solution that was kind of satisfying to use, but it's so small that it doesn't even have room for my full set of pliers, and the magnets aren't quite strong enough to hold the heaviest pairs. You can see right there, I have to try twice to get this pair on, and it's barely on there. It's also in a very inconvenient location. Whenever I'm working on top of the standing desk, it's really easy to knock off these pairs, which I have to store upright because this thing is so small. We need a better solution. I want to be able to drop these pliers into a slot, know that they're super secure, and just walk away. I can use my calipers to figure out what the width of that slot needs to be. So with that width, there's still plenty of handle to grab. They're not trying to flip over, so I think we can use that. And looking at the dial calipers, that is 1.775 inches. We also need to know the depth of that slot so the handle can fit inside, and that's 0.75 inches, 0.75 inches. We need to get some dimensions off of our mounting screws. The screw head diameter will tell us how big to make our mounting holes, and I'm gonna leave this a little big so that the screw can fit in there comfortably. So that's 0.275 inches. And then the shaft diameter, again, we'll leave this a little big so that the threads can slip through the hole. Call that 0.15 inches, 1.5 inches. We also need to know the diameter of our screw bit so we can create a hole to actually screw these in place. And again, we want a little bit of extra room, so we'll call that 0.3 inches. So those are really all the measurements I need to model my first tool holder. And I'm gonna use Fusion 360 to do this, but as you'll see, the 3D modeling we're about to do is so simple that you could probably do this with any basic 3D modeling program. We'll start by bringing all of our measurements into Fusion as user parameters. So I'll click Modify, go down to Change Parameters, and add my first parameter, which is the width stopping point. That one is 1.775 inches. The next one is depth stopping point, 0.75 inches. Then we have screw head diameter with our little bit of clearance is 0.275 inches. Screw shaft diameter, 0.15. And then finally, the bit diameter is 0.32 inches. I always like having a wall thickness parameter whenever I'm doing 3D printing, and for this, I think 0.1 inches will be good. Click OK, and then we can create a sketch. So I'll hit R for rectangle, and I'm gonna make a rectangle that is our width stopping point. Hit Enter, and then hit Tab by our depth stopping point. Hit Enter, and that is the interior of our slot. Then I'll double click that rectangle, click Offset, and offset that outwards by our wall thickness. At this point, I'm gonna add one more parameter on the fly, and that is going to be our height of our tool holder. And I think 1 inch should probably be good. Hit OK. Then I'll click inside my rectangle, right click, Extrude, and I'm going to extrude this upwards by the height tool holder parameter. Hit Enter, and there we go. There is our basic tool holder. So now I'm going to create a new sketch on the front of the holder. I'm going to hit the P key on my keyboard for project, and I'm gonna project that inside back face of the tool holder. So now those interior lines, those interior corners are projected onto this sketch as lines. And I'm gonna create a line. I just hit L on the keyboard, change that to a construction line, and I'll draw a line from the midpoint inwards by the bit diameter user parameter. And then at that point, I'll create a circle, C for circle on the keyboard, and then I just clicked on the point. That is bit diameter in diameter. And I'll do the same thing on the other side. So I have a construction line out from the side by bit diameter, C for circle, click construction, and then that is going to be bit diameter. The reason we're doing this is our screw holes are going to be on the back of the tool holder. So we're going to extrude out these two circles, and by cutting through our body, that will allow us to actually pass our screw bit through our holder. Click OK. So there we go. Our screw bit will pass right through those holes. And now we have to make a new sketch on this inside back face. We will project those 2 circles to the back. So I'll hit P on the keyboard for project, click on one circle, click on the other one, click OK, and then I can finish the sketch. So we're only really using the points inside these circles, and we're gonna use those to locate holes. So I can click hole, and I'm gonna make 2 holes, one at one point and one at the second. And by selecting a countersunk hole, we can make a hole that is countersunk for our wood screws. So the width of the countersink is our screw head diameter user parameter. The width of the shank is our screw shaft diameter. So screw shaft diameter. And I'm going to go ahead and measure one of my screws. And I can see that the thickness of the head is about 0.1 inches. So that means the countersink should basically extend the entire thickness of our piece. And I can see now that it doesn't. Rather than play with any more dimensions, I'm just going to change this angle until the countersink extends through the whole thickness. So I'll change it to 60 degrees, and that looks pretty spot on. Click OK. And there we go. That is our first tool holder modeled and done. We can go to 3D print. All right, so there is our tool holder on the build plate. I'm printing it out of PLA at 0.15 millimeter layer height, and I'll click slice just to see what that looks like. So we do have some overhangs going on, but because it's a gradual buildup to the overhang with a circle, I know from experience that my printer can handle that, and I'm not going to use any support material. Now, because our wall is so thin, I don't really think having an infill is necessary. So I'm gonna go to the print settings and turn the perimeters up to 4 so that we print this entirely with perimeters. And what this does is just make the whole print a little cleaner. It causes less vibration on the printer, and you can see that it didn't even increase the print time. 1 hour and 12 minutes to print. That looks good. So let's export the G-code and see what it looks like. Changing the original design to fit every set of pliers was super easy. All I had to do was measure the new width and depth of the stopping point, update that in my user parameters, and instantly I had a perfect tool holder for every set of pliers. I found this 2x8 on the side of the road, painted it white, and I'm gonna use this to mount the tool holders. So we got our crescent wrench, channel locks, big pliers, side cutters, small needle nose, small side cutters, scissors, find out if there's actually a stud here. Oops.
I see a stud.
That sounds promising.
It does.
Sorry?
She's like, I'm delicate.
Oh wow, I kinda got it level on the first try. It's not going anywhere. Super happy with these tool holders. I love how easy these are to reproduce, and this board has tons of room for expansion. I already made another one for one of my favorite tools, the Japanese pole saw, and for this one I left a slot in the front because it has a really long handle, and that makes it a lot easier to take out and put back in. Thank you so much for watching, and if you're interested in supporting this channel, I have both a Patreon page and an online store. I'll leave links to both of those in the description, and I will see you in the next video.